Hi everyone, I'll just give a few more minutes because there are people, well, Ryan, in particular with items on the agenda. Right, so let's get started. Welcome everybody to the May 28th SIG Multicluster call. And on the agenda we have Ryan first, but he's not there. So I guess James, if you're ready, you can.
Yeah, sure thing. Let me try and share my screen and do some reorganizing too. Cool. So yeah. Which one is it? Desktop one. Sweet. You can see that okay?
Yeah.
Awesome. So yeah, I thought I'm here today to kind of chat about a project and idea that I've been putting together for a few weeks now, and it's kind of born out of some of the ideas in KCP of workspaces, but it's kind of evolved from there into more of like a transparent proxy layer. So I'm kind of here because I'd like to find a home for this kind of in the community and see if there is broader interest in the idea in the first place. So yeah, the idea then is like workspace is a concept to improve the multi-tenant experience with Kubernetes. So kind of background is when you're kind of using multi-tenant Kubernetes, you can't do things like cluster scope watches, cluster scope lists. You can't interact with clusters in kind of in a normal way if you did normally have like a whole big cluster to yourself. You also lose things like cluster scope permissions, so cluster roles, cluster role bindings. Instead, people have to create roles and role bindings, and like HNC has approached this with copying and like through the hierarchy. But again, it's more changes and differences, and also namespace creation too, which again HNC has touched on with things like prefixing, and generally that's made kind of multi-tenant Kubernetes experience second rate compared to if you actually do have a whole cluster. I think that's also a problem when it comes to adopting even some of the multi-cluster tools that are made in SIG Multicluster, but also any other operators that don't support either a list of namespaces or whatever else. And it's pushing that onus onto the client to manage. So the idea of a workspace is similar to HNC, a logical grouping of namespaces. I haven't touched on kind of full hierarchies and trees because I think I'm keeping it simple to begin with. But it's a basis on which we can then build kind of more flexible primitives. So it gives us a cluster scope view and a cluster scoped storage. as well as things like watches, lists, and everything across your sets of namespaces. It's effectively, from a client perspective, you're creating multiple clusters. You're not really, because you're limiting, like you're still using a shared scheduling domain. We're not exposing like node objects or certain other objects types. It's really kind of focused on namespace resources, plus some of the bits here for RBAC and so on. Rancher has a similar concept of this too, and that's a grouping of namespaces as a project. They don't, as far as I'm aware, have anything like a list watch or like cluster scope storage for these projects, aside from perhaps in their own data stores, like external to Kubernetes. So I'm going to quickly just kind of step through before I go on and just show people, just so, yeah, we can get an idea. I've also written up this stuff and included the details on HackMD too. But the idea, I won't go through this whole thing because I've already set this up in advance. The idea is though, we've got a kube config file here. This is running in kind, but this is kind of pointing to the real cluster. There's a wildcard one. I'll talk about that in a bit. But here, these are kind of like our workspace scoped endpoints. So it's /clusters/backend team. This is borrowing KCP terminology because there's some like client tooling that we can then lean on when it comes to building this stuff. But this kind of runs distinctly. So from KCP too, it's able to run. It's kind of like a standard API server. So if I do, first of all, kind of get namespaces and say context equals finance, you can see here I've got my limited set of namespaces exposed. If I do, I think the other one's backend, yeah, here. We've also got ops as well, which is another one. And if I do just get namespaces, I guess I should show this first in kind. This is kind of the back end that we're seeing. One thing to note, it's not so easy to see, but like default is not assigned to a workspace, so it's not showing up in any of these. And if I do, we've got a wildcard view as well, which I mentioned before. And you can see here, this is kind of all of the namespaces that are assigned to a workspace, hence default doesn't show up again. That goes to all the other resources. You've got, here we now need to switch to doing a cluster scope list. You can go through and you can see here, workspace as a column. This is just adding it in at the end of like the table printers. If we go along and do get context here, finance. Sometimes nice to actually just do the get all view. You get to see everything across everything. But you can see here, this is giving us our cluster scope view, but it's scoped down to just what we get to see. Let's see, I think, yeah, I guess I can quickly, I won't go too much into it because I think it's better to go back to the demo, but this is kind of what's powering that mapping, and I'll touch on some of the expectations on how we do it. This is kind of a low level primitive that I think, you'd build upon with something more like maybe a workspace definition object, or possibly integrating with, if you were Rancher, I don't have an affiliation with Rancher, but if you were, you might have a controller that watches for, your own project definition of some description, and from there mirrors that into a workspace configuration. And there's some things to talk about on authorization there too. But yeah. Going back there, I mean, I can pause for a second if anyone's got any questions. I might have answers to them in later slides, but if anyone's got questions now, I'm happy to take them there. Yeah.
Yeah, thank you for this. That's pretty cool. I got two questions, I guess. One is, are those namespaces across multiple clusters? And if do you do sameness and kind of things like kind of what's been described in the SIG multicluster? And the second question is, how do you handle conflicts on CRDs, let's say, like the actual cluster objects? Is like, how do you handle potential conflicts there?
Yeah, so first of all, no, this is not spanning multiple clusters. I kind of touched on this and looked into it, and I think there's, they'd certainly be exciting. The resource version semantics for that, though, are not easy, to say the least. You're going to need to be able to like reclock. I'm just going to move it back over here so I'm not looking aside. You'll have to like reclock resource versions and things like that, which makes it very complicated because you've got different streams. So this so far is like really focusing on like the single cluster experience. I think there's broader ideas at a certain point. Once you detach from the idea of being assigned to a specific cluster, you could imagine a workspace a workspace scheduler, say, and choosing a home for them. But no, as you see here, and I think the general intent of the project is that it would be assigned to a single cluster. And then you build multi-cluster primitives on top of that around the idea of a workspace. I think namespace sameness, I'll say it fits perfectly with this model. Because if you have that you can imagine like a workspace name that contains something like a cluster name to key on as well, and then your namespaces are the same across them, and then having multi-cluster controllers over the top actuating into those. Stephen, you've also, I hope that answers the question. Stephen, you also your hand up.
Yeah, I was wondering, so essentially this is a layer on top of namespaces, but it doesn't introduce isolation. Well, there's RBAC on the namespaces, but there isn't an actual hierarchy of namespaces inside a workspace. What I mean really is that you can't create two different namespaces with the same name inside two different workspaces.
Correct. Yeah. So and that was actually your second question there, Corentin, and we did go on it in a couple of slides time. But that's totally right. We're not trying to like hide the fact that there is one cluster in the back end. Ultimately, there is still one. So like sameness works great with this, because between different clusters, your workspace could actually exist because you have that set of namespaces, like those namespace names reserved. For other cluster scoped objects, at the minute, the only ones we expose to users, and I'll touch on how, is the cluster roles and cluster role bindings. And namespaces, I guess, is kind of a filtered view in how it's done here. Things like CRDs, I'll talk about in a bit more detail. It is possible for us to do that, but it's actually garbage collection and owner references become more problematic there. You can get this set up with having CRDs stored in a separate etcd, and suddenly this becomes a stateful proxy with like CRD storage and things like that. Its garbage collection becomes a problem though, because on the backing Kubernetes cluster, it's running a garbage collector that doesn't have a view over those CRDs, so it will be deleting the objects. So for that, there's ideas we've had, speaking with KCP folks too, on like owner reference rewriting into annotations, but it gets into a whole other world. And right now, I think I kind of want to focus on delivering workspaces as a concept. And I think like the discussion on how we can do CRDs there is, it's a later one. And I think there's quite a lot of conversations to have around how to do that. Conversely though, because it means we are able to expose a limited set of APIs from the backend cluster that might be CRDs. I'll go into it more because I should carry on with the other slides. Like the service provider case here is actually quite helpful. Like the idea of a workspace or a view across namespaces, you can imagine actually using the same sort of technology to denote which namespaces opt into a service provider, say like managing their resources. And we can provide a similar view like a workspace is across just the namespaces that the service provider has assigned. So that's a whole other thing. And it's more building on the same technology rather than workspaces themselves. So I don't want to muddy the water and confuse things just yet. But yeah, we don't expose custom CRDs per tenant at this point. I'll keep going through. So yeah, I suppose I should really have started with how, because I hadn't mentioned its proxy by this point in the deck. So yeah, it's a stateless proxy layer on top of kubeAPI server. So it could run in cluster next to it wherever you want. It's built upon the standard like Kubernetes API server watch cache and using some of the work that API Machinery and Stefan have been doing on the generic control plane to help like build all of this together. But for the most part, what you see is actually the standard kubeAPI server REST storage providers and things like that exposing it. Workspace scoped objects go into a system namespace that is designated per workspace. So that is effectively rewriting, like from the user perspective, they see cluster scoped objects, they see cluster roles, everything's normal. But in the proxy layer, we're actually rewriting those into namespace scoped objects and persisting them. There's another nuance there on, again, owner references to cluster roles and cluster role bindings would then sort of go a bit wonky. So I think the idea of, look, for now at least, the workspace scoped, like the list of workspace scoped objects, I think will be limited for the time being until we work out like a generic way to handle owner reference management and things like that, or if we just reject it and don't actually allow people to create those kinds of references for safety, because we'd prefer like correctness there. And so, yeah, as I say, remapping them. I'll talk about authorization in a bit, but at the proxy layer, we're doing authorization across that set of cluster role bindings, cluster roles, and role bindings, just like normal. For how we'd authorize requests within the backend cluster, if you would only be authorized by a workspace role or a workspace role binding from its view, we'd probably look at an authorization webhook, but that's a little bit further along. Yeah. Please raise, this is quite complicated stuff, so actually please raise your hand if you've got questions too, and I don't mind stopping. There's not too many slides. I think we're more than halfway. But yeah, you can see here, like users send requests with kubectl or their operators via the workspace API server. These are effectively like that /clusters/finance or /clusters/ops. It all goes through to a single like workspace API server binary. This dotted box at the top is actually not very well placed because all of that, it actually extends all the way down to include the watch cache here too. So the watch cache is basically being fed from the standard like backing API server. It's sorting it into correct buckets based on the workspace assignment for that namespace. So it can then serve efficient watches out to those clients. And you can see here, we've got like the system namespace store, it's just kind of drawn on the side, but yeah. Oh yeah, Correct.
Sorry, another question. So does that, it sounds like let's say you have a cluster scope RBAC role binding, then you're creating an RBAC role binding on the system workspace namespace?
Let me just show you, because that's probably the easiest, and I've got it all up and running here. And I kind of rushed the demo, I think. kubectl get cluster role. If I do that here and do like on the client cluster, you're just going to see like a normal set of cluster roles. There's nothing on there. So if I do here context finance, you can see there's this like workspace admin one. The actual semantics on how we do this longer term, like the workspace admin piece, is TBD, but you can see there from like the user perspective, at the minute, you can see there's actually an annotation. This is to do with how the watch cache is fed, denoting which cluster it's in. But you can hide that from the user if needs be. But you can see this is a cluster role binding, absolutely standard. In the back end, though, we actually have a CRD, which is a workspace role and a workspace role binding. And these are namespace scoped CRDs. Role binding, which means I also have to do, that's because I went to the wrong point. You can see there, these are actually namespace scoped. And they're actually, we've got a namespace denoted for each one of these different workspaces, which is persisting them. Right now, I need to do a little bit of extra rewriting so that the authorizer on the kind side would work, because this should actually, you can see here like an artifact of the fact that these, from the user perspective, are cluster roles, in that like I've specified it as a cluster role, so that's still there. These would probably be rewritten too in the backend as they're stored, so that an authorizer running in like the main backing cluster can run like the RBAC authorizer again to authorize those requests to itself. So effectively everyone's aware of all of the different roles and role bindings. But because on the, if I go kubectl, if I do a kubectl get role binding, cluster role binding -a, admittedly, we don't have any roles or role bindings. These are stored in the backend cluster. But the authorizer running at the workspace API server sees this view because it's running on it, like just like any other API server would, looking at its loopback connection. And it sees these cluster roles and cluster role bindings for that, so it authorizes based on those. read requests are what is served by the Workspace API server because it comes from the cache, right? For write requests, impersonation is used. So this also acts as an authenticating proxy. You could stick another whole proxy layer in front of this to do your authentication and pass through things if that's how you want to set up your platform. But yeah, the idea is that the write requests get passed through, so then the authorization for write requests would actually be performed by the backend cluster. So the actual overall permissions that this component needs is global read permissions on that backend for everything that you want to expose through, at least. So not nodes or anything, but all other objects you would. And then impersonation permissions, no write permissions explicitly, which does keep the audit log on the backend cluster, obviously a lot clearer. We're not messing with things there. And then reads, you would need to make sure you have audit logging set up on your Workspace API server. So you still have visibility into that. Cool. So yeah, this is largely, I'd say, focused on multi-tenant Kubernetes platforms, wanting to enhance that user experience. For like end users, I guess there's certainly more end users, I think, but one pain point I think we've seen is like people wanting to run controllers over their set of namespaces, and otherwise having to set up things that are dynamically adding new namespaces to a list or removing them and stuff like that. But that you still need to have some kind of definition of which namespaces are which, and that's kind of partly here what I'm hoping to address, which is giving a standard definition for like what a group of namespaces is. Yeah, gives a more native kind of experience with these platforms. Feel like if you want to see what you can see, you do kubectl get namespaces and you get to see it. The idea, obviously, behind any kind of a platform like this is allowing a larger shared scheduling domain, which is why we kind of have this type of cluster to begin with. There is another scalability property, which is more just a property of any watch cache in front of an API server, but we actually shift user requests here to at least watch or read requests to the proxy layer. So there's a small benefit to be had there in that you're kind of protecting your core ones somewhat, not really entirely, and notwithstanding other Kubernetes primitives like priority and fairness for that. But yeah. I think the eventual idea here, it touched on some of the things that I think H&C also talked about at points, I can't remember, or some projects in this space have, is things like resource quota moving up to I guess the cluster scope from that perspective, but we'd like to look into ways we could do that to permit, say, delegating permission to manage resource quotas in namespaces to a workspace admin or something. And yeah, namespace creation, perhaps potentially with like prefixing used, so you can create up to 10 namespaces as long as they have this prefix, is something we could possibly look at enabling too. Yeah, some of the principles to all of this is not becoming responsible or on the hot path for anything that Kubernetes is currently rated to do today, really. So that's not running the controller manager, not wanting to do scheduling. We're not creating pods. We don't do any of that. This is an API server proxy. It's lightweight and sits on top of the API server. There are, I'll go into it in a bit, some changes to Kubernetes that would be advantageous to this, but not required. But this should be a completely distinct component that you can drop in front of any kind of Kubernetes distribution today. Another one's interoperability. So you should be able to use the Workspace API server to do whatever actions or interact directly via the main API server. And the only thing you lose, I suppose, is say the workspace role binding, although you could still be authorized for namespace scope requests, but you lose your cluster scope view because obviously you're not going through the proxy, which kind of makes sense. But those clients should be able to interoperate. We shouldn't be breaking any resource version semantics or optimistic concurrency guarantees or anything. And also conformant, at least for the APIs that we expose. That's something I need to really get into. It's been quite a lot to get it to this point. And it's kind of why I'm here too, because I want to make sure I get some kind of feedback on it too as we go. Yeah, this is kind of now going to more So some of the things that would be advantageous, things like being able to support consistent reads from our cache. We can utilize the consistent reads from watch cache ket work. If in a similar way to how they use request watch progress on etcd, we have a similar API in the API server for requesting watch progress on the watch from our cache to the backend cluster. We can actually also serve consistent reads there. So I've POC'd some things on it, and you can certainly do it. It's yeah, we'll see. I need to check. I don't think we actually do need any changes in the cache here, this second bullet point. That was actually more a note for myself. We don't actually, I don't think we need changes in the Kubernetes like standard cache implementation, because we can just replace the key func used in there. There's, yeah, also potentially really unsure. We could do like workspace roles and workspace role bindings as standard roles and role bindings. You'd need to look at relaxing validation rules. It would take quite a while. You'd need to teach the authorizer how to traverse and look at other objects. I think that'd be a larger thing to do with SIG-auth longer term. Yeah. Why are we doing it? So the generic control plane work has really helped to enable all of this. KCP has provided a lot of kind of inspiration on it too. That's why you see reference to it kind of throughout at the minute. I've been working because I think this is a great primitive for KCP to be able to adopt into its project, as well as these other things, if they want to be able to expose like workload types within a KCP workspace hierarchy. So yeah. Yeah, we want to be able to actually do this in an open space because like within the Kubernetes SIGs kind of organization, because I think there are a number of different places that are building similar sort of abstractions, like the idea of groups of things. I think it aligns well with namespaces and the like. And I think, yeah, it would be great to actually be able to collaborate on those sorts of common definitions for it. And I think there are a lot of similarities with the hierarchical namespace controller. In fact, this could even be like I think I've even seen there is a pull request merged a couple of months ago, which adds a similar thing, but as a API extensions API server, which has a few limitations within HNC too, which I should probably drop a link to on here, because that was very interesting to find the other week. And then, yeah, this is the last slide, which is just a bunch of extra ideas and things that we've been kind of looking into around it. So as I mentioned, CRDs, there's certainly a possibility there, but I think that's probably more of like if we can get this into this space, I'd like to have a conversation like around what the principles are of this whole thing, and if that is a goal, and if it is, then how we do it, I guess. Looking at possibly allowing swapping things out for the workspace scoped object, that's more technical. The front proxy idea I touched on, which I think helps with like portability of workspaces. And again, that's borrowed. The front proxy is mentioned GKE Enterprise Connect because I discovered that the other day, but that's a component in KCP today, which is specifically to allow mobility of like your workspace to shard assignment to eventually allow like migration of workspaces in KCP between different KCP instances, which isn't quite what we're trying to do here, but you know, I think it's, yeah, got some history. The authorization webhook, namespace prefixing. Yeah, these bottom two, I think, kind of touch on the same thing. And this is actually, I guess, stepping on the toes slightly of like virtual workspaces as a concept in KCP, which are these similar sorts of views. Like what I've talked to you here is workspaces. These are almost like views over namespaces in an existing cluster. Multi-cluster workspaces, kind of you mentioned earlier, is something you could certainly expose. You probably wouldn't be able to do things like watch semantics over them unless you have a very, very clever clocking mechanism that everything could work together with. But you could probably do a list, although I think there are some, yeah, you could do a list for like convenience, I think. And then the service provider specific stuff, I think, is quite an interesting one as well. But anyway, I've talked a lot. Thanks for listening, everyone. If you want to see any more of like interacting with it, I'm happy to poke and prod on the CLI, but otherwise the links are there too, that you can step through, like the full output that I've basically forgotten to go and show you all of. Yeah, and I don't know if there's any questions. Oh, yeah, Tim, hey. You're muted, or I just can't hear you.
Yeah, he's muted.
Lucy, do you want to go? I see.
Okay,
Tim.
I'll go. I take the waving hand as Tim fixing his audio. That's okay. Yes, this whole project is very interesting. I think that when I see this project, my speculation is that most big organizations and companies that are using Kubernetes across multiple clusters have in-house built some version of this. I've seen it where I work, but I've also seen it at other companies. And my follow on here is, if we go talk to them, can we get their learnings about how that went and take those if we're going to effectively, because to me, this looks more like for the big, the people who'd be most excited about this are those big companies, because finally they don't have to maintain this proprietary thing anymore. And to me, it feels like it would almost be a consolidation of those platforms. But do shout if you think I'm wrong, folks. But I would speculate that pretty much every massive company has some version of this system already. I know at least we do, but it's just inferior to this one. It doesn't have all the fancy bells and whistles.
Or you could call them scary sharp edges potentially, but yeah.
Yeah, you could call them both.
That's why I want to do it with everyone though, because yeah, it's important to get right. How are you doing, Tim?
How about now?
You're good.
Yep.
All right. Bluetooth and Linux, like peanut butter and I don't know, something terrible with peanut butter. If so, James, finish this question. If Kubernetes just did X, then none of this would be necessary. Is there a value of X?
So, I mean, you could say if Kubernetes went and supported something like precisely this, like you could go and build it into core. I mean, that's one thing. That's probably not the answer, the question that you're asking though. I think
nested namespaces.
Yeah, cluster scope views over thing, but that is basically what we're saying here, right? Like having a nested namespace with the ability to have, it's being able to do those watches across them, I think, and have a space that's standardized to store metadata about a group of namespaces. So you could call it nesting, or you could call it a namespace group as an object, and then a namespace group suddenly has to fit into its like REST model where cluster scoped objects go. Or namespace groups, scoped objects. It's like a common administrative space, I think, as well as bringing those benefits that you get of like the list watch. So like, I don't think there is one thing that Kubernetes can do. You can defining a group of namespaces, I guess, is a thing.
I guess that's the answer I sort of expected. Would that actually be sufficient? It feels like there are things happening here that are more than that. I can't tell if they are opportunistic or if they're actually fundamental.
Yeah, so I guess what some of the things that, like the further bits in this is bits I've talked about before with like resource version, semantics over like the mapping that you're like, we can dynamically reassign namespaces like to different workspaces in this model. And that's, you know, that same technology is what would now enable us to do like a service provider view, where we could add in namespace, like a namespace could actually even be a member of multiple different views. In order to do that, there are like resource version things going on that I think are integral. And there isn't one change in Kubernetes that would allow them to do that, because you'd end up having to do the same thing. Because like you could say, we'll go and store all the objects under like a nested hierarchy in etcd, but you still don't actually solve that. Like, okay, but now I'm watching things across like a partial view of every one of those hierarchies. So yeah. Like the RBAC stuff with label selectors helps, but it doesn't actually solve the problem because it only applies to the objects that are labeled. So you could run a controller or something which again is basically what this is, that goes and annotates objects in some form with that annotation or label that, or I guess label that you can define in role and role binding. So this is the SIG auth-kep that's over at the minute on adding label selectors as a RBAC authorization, like property that you can authorize on. It would then require you though to somehow label every object in every namespace, which is fine if you do it for like new namespaces, but if you're ever migrating things or wanting to expose something through multiple different views, it's not really so possible. Sorry, I rambled again then. I've had my head too much in this, so. Yeah.
I have follow-ups, but I want to let Lucy go because I want to think about my question.
Okay. So to me, and do shout if you think this is wrong, this almost feels like what you effectively want to build here is federation on top of Kubernetes, in that you want a namespace effectively federates into multiple clusters and then is reconciled on top. If that's sorry, does that make any? Hopefully that makes some sense, because it almost feels like to me this is what we're going for here.
So that's not. So that makes sense what you're saying. That is actually specifically not what this is trying to do here, though, because this is meant to be as like a single cluster view. I think to do that, you know, you need to somehow have, if you want to expose like a watch, you need to have like a synchronous, a way of synchronizing all those events everywhere somehow globally with really special codes that the likes of Google have. Yeah, this is very much a single cluster view here. I think the multi-cluster, like I want to be able to use multi-cluster efforts in multi-tenant Kubernetes, I guess. You could, yeah, like I can see us having like those regional sort of workspaces that then sync down into other workspaces, you know, however those projects go like this, but that I don't think that's trying to solve for it just here, unless we build some like pluggable, but that's almost another project, right? You could build a whole thing that gives you that, and that has a pluggable clock source that's synchronizing for everything across the world. But I actually think that's a different project. Yeah, that's also really cool.
Okay, yeah, that makes a lot of sense. Cool.
So I try to be really careful with the word federation because it has so much baggage in this SIG.
True.
You know, on one hand, I love the idea that clusters are irrelevant. In fact, it's written on my little whiteboard on my desk right here. Make clusters irrelevant. It's a very artificial boundary that I don't think users are super excited about. Like it's not relevant to the problems that users are really trying to solve, but we make it an important piece of the machinery. Finding a way to erase the boundaries between clusters feels really like a stretch. Like I don't think it will be fundamentally the same API, and I don't think it'll be completely transparent. I think, you know, in the past, this is where federation has fallen over, is trying to hold to the idea that I can just pretend that multiple clusters are one cluster and it'll be okay. It won't. I totally lost track of the other half of my thought. Oh, if we had something like a group of namespaces, which we have talked about before in the past, we've talked about having a concept of a tenant inside of a cluster, which seems like the obvious, like major piece that I could extract from this idea and say, let's go do that. I don't think it would actually solve your problem though, because it wouldn't easily give you the ability to move a workspace, for example.
Right. Yeah.
The tenant is more of a point in time decoration than a fundamental like piece of your URL path.
Yeah, I think the fact like unless you, yeah, I guess what you could do if you forget groups of namespaces, you don't get the nice benefits of having multiple namespaces, but you could do like the front proxy approach. Your namespace name is globally unique because of namespace sameness or whatever else. And then you could do like namespace assignment to a specific cluster in a fleet. And you could kind of argue that that's similar. You're doing like an assignment. I think it depends though on what it is that you want to offer people. Do you want to offer people multiple namespaces in that way too.
In my mind, the need for this front proxy is the smell. It's the thing that I'm trying to figure out how to avoid, because I'm sure it's true inside your company. It is definitely true among our customers. There are very few people who have one cluster, and the same workload often runs in multiple clusters. And so the idea of having the same namespace across multiple clusters that are working together for whatever reason, right? Maybe it's multi-regional services or who knows what, is pretty important. And so to say, well, you have a workspace view, but it's bound to one cluster, means I end up with a workspace for every cluster for every tenant, which is seems like a dead end.
So that's basically it. Like here, you end out with, for each one that you're assigned to, you have exactly that. I guess this is where, though, I do see exactly what Lucy's talking about, building those other views on top, be them, globally synchronized clocks that give you watches, or be it something more akin to what Federation has done, where you have like a separate API server or workspace or something that contains like those regional deployment or whatever you want to call them, style definitions, and then is doing something like splitting across them. I in my mind, eventually you get to the point of having like a similar to a system volume claim. You might have a workspace claim with an associated like quota ask attached to it. Something then binds that to a physical cluster. You can then scale up into that, with your workloads from your regional controller. And if you're decommissioning a cluster, for example, you could taint that cluster like you've talked about previously in other things in the SIG. You could like taint the cluster, have workloads drained from the cluster, where I guess you'd create another claim for like another workspace to like claim that capacity in somewhere else to maintain your availability needs. Drain the workloads from there and into the other one. And then that's effectively like the decommissioning piece that you could kind of build around this. Again, I think it comes down to if you want to do this at the group of namespace level or the namespace level, though, because you could exactly the same way, you can create a namespace claim, which is for that same name, the name's static across all the clusters, but you're effectively claiming that capacity in one of the attached or known zones or clusters or whatever you want to call them.
Yeah, I suspect that some sort of a namespace ownership system is important building block for any such system. I keep coming back to like, what could I teach Kubernetes to do that would make your life easier?
I think part of it as well is if you think about, if you go back to the idea of CRDs in here, like, and actually using this as an API boundary too, which is certainly like a common ask, right? Like as from as well, like KCP exists to also give kind of that, the CRD, well, one of the things is to be able to give different tenants and different workspaces their own set of CRDs, which is certainly does help in multi-tenant systems with like CRD schema changes and stuff. It's getting easier to manage CRDs at a global state, but it necessitates kind of like a provider user relationship where they're like responsible for managing those schema changes and availability, and that can be a big issue at a certain point. I think if you consider that, and if we can say, we do actually want to build that into it, that's when having a single namespace doesn't really work in that same way. I guess unless you say that CRDs can be installed within a single namespace only, and then you are creating the namespace custom resource definition object or something. But suddenly at a certain point you have to ask why we don't just have groups of namespaces, and then just maintain your like standard REST path structures and things like that.
I mean, it seems, I see like it would be not easy, but possible to add a concept of a workspace or group of namespaces, build it into the URL path, have a legacy like non-workspace namespace concept, migrate there, teach it about CRDs, but actually that last step gets really complicated because discovery is fundamentally different. So like, it sounds like a fun project, but it's probably a 5-year project.
Yeah, and this is kind of why I like you could like workspace, like the proxy thing can be a smell, or it can be a really neat way for us to actually experiment with this sort of stuff without getting too stuck in the weeds of it, I guess.
Yeah, please don't take my comment about a smell as a negative thing, right? Like every dirty trick and hack that we pull teaches us something about what we're missing, really.
And I've tried to think of ways that we can just sort of embed this into Kubernetes in a way that is not massively going to be like massively controversial, because it is quite a significant change to Kubernetes to support anything like that. I think, you know, Stefan's here as well with KCP. It is a very, you're basically touching on what KCP is doing there if you do it directly in Kubernetes. Yeah. I think you're basically adopting KCP as Kubernetes, basically, and getting rid of the bit where they got rid of pods and services and workload types. Yeah.
The chat just pointed out there may be other agenda today.
Yes, yeah, I was going to say to time check because we've got less than 15 minutes left. And yeah, this is a really interesting topic, and I agree that the hierarchical namespace controller sets a precedent for having something like this in SIG multicluster, although there might be other SIGs that could be interested as well. But yeah, definitely bring it back. We could spend hours and hours thinking through it, definitely. There's probably scope for discussion on the mailing list and not just waiting for the next call. But yeah, there are other agenda topics. So I said I told Ryan we'd come back to his topic since it was first in the agenda.
Sure. Let me see if I can share my screen. How do I share my screen? Oh, yeah. Yeah, this will be quick because where's my cup? Can you see my screen?
Yeah.
Oh, you can see it. Okay. So yeah, this CAP PR has we've worked a few iterations on this CAP PR, and I think we got a few look good to me on this PR now. Just want to get more community-wide sign off on this before we can merge. In short, in this time, we defined the relationship between the cluster inventory and the cluster set. And now we have a formal definition of what is a cluster inventory, which is really just a group of clusters, instead of going into details into put more restrictions on that. But what's the relation between this and the cluster inventory is now cluster set is now that cluster set is kind of a special case for the cluster inventory. And we put a few constraints on the when the cluster inventory is a cluster set, then they need to be all the members in the namespace needs to belong to the same cluster set. And we also give some suggestions on how to consume the APIs, which is not, hopefully not controversial, because this is practically every project I see how they use this cluster profile APIs is using a hub cluster and POC those APIs or the CRs on those hub cluster and allow another controller to operate on them. And I hope that's not too controversial. And other than that, it's a pretty short PR. If anyone else have any suggestions or comments, please feel free to leave those comments. Otherwise, I think it's kind of in good shape. There's one follow-up. I think Stefan opened a follow-up CAP PR on the credentials. I think as soon as we close this one, we should move on to that one, have a discussion on that one, because that is directly the next topic we need to discuss before we can really integrate with third-party applications like multi-queue and the Argo CD, or even something like this today's topic. Because today's topic, I think, is really focused on single cluster. If we really want it to be multi-cluster, we need something, some gap, some bridge for that too. We can see if there's any way we can make that work too, if anyone is interested. That's it for me. Any questions? Just some technicality question like, oh, how can we get this merged? What type of approval do we need to get this merged?
I think it has to be Jeremy
Has to be
at this
Jeremy.
point. Yeah.
Okay. Sorry, I was late. Was he out or something?
Yeah, he's out today.
Okay, so I will ping him. I think if we get a few more local to me, it probably is easier to for him to approve this, I guess. I'll
So
ping him.
actually, I think, isn't Jeremy out like on a family vacation or something? I think he's out not today, but like for a couple of weeks.
Oh, yeah, I
I
haven't
could be
been able
wrong.
to-
I thought that was what he said.
Yeah,
Yeah,
it's hard to find him even on Slack, so I'm not sure. I pinged him a few times. I will see. I'm not sure. Yeah. Normally, what do we do in this case?
If we get all of the ducks in a row and everything's happy and the folks who are also reviewing it, I can't actually see on the screen, but whoever is assigned as reviewers, I can approve it. And I think we can make an argument that because the formal approver was out of office, we can get an exception for that, I think. So do the work as if he was here. I think the set of reviewers who are already looking at it will probably be able to represent what Jeremy would say.
That'd be great.
I know I've had this on my plate to take another look at this too, and the other things have taken priority, but this is now my first priority again is work that I owe on this, reviewing and revisions to the MCS API, which I believe is John's topic next.
Cool. Yeah, it's a good segue to the next topic. Thank you. How do I? Yeah, just I don't know how to. Oh, stop sharing here. Okay.
all right. Thanks, Ryan. John, over to you.
All right, thanks. So yeah, a couple weeks ago, I started working with Jack to get the MCS API graduated to beta. And I wanted to try to get the EDE tests that were already in there up and running and hit a few issues related to dependencies, which were a couple years old. So I took a stab at updating all those dependencies just to get the EDE tests to run for me, and I got them working, which is cool. So I would like to get that PR merged sometime so I can keep working on those next end-to-end tests. So I know Jeremy's out today. I don't think Laura is here, but I think they're the main ones with approval permissions on that. But if anybody else wants to take a look in the meantime, that would also be great. So yeah, I know Stephen has taken a look, Jack has taken a look. So thank you for that. I think that's pretty much all I wanted to mention.
All right. Well, thanks for looking into that. So yeah, it's only, well, technically Paul, but it's unlikely that he'll take a look at it. Paul Murray and Laura and Jeremy, you can approve. Ryan, you've got your hand up. Oh, sorry, Mike.
Oh, just a question about Paul. Like, is he still active, or has he like officially stepped down? Or I wasn't quite sure.
Yeah, well, so the general idea was for he hasn't officially stepped down. And the plan was for me to become co-chair with Jeremy, but Jeremy's busy, Paul's even busier.
I mean, I think it's
Gotcha.
fair to move Paul to emeritus. I don't think he would object to that.
Yeah.
And I think there's no contention in moving you into the approver list. So We just need somebody to approve that approval change, which I don't know if I can do, but we could try.
Right. Yeah. So I guess I should write the PR then.
If there is a PR, we can at least like flag it as like this is a machinery movement. We can get somebody with super privilege to fix the situation.
Yeah. All right. Thanks. Yeah, Ryan.
So I think I'm not sure. I'm looking at the PR. I'm not sure if we have any, because I remember there was a discussion about moving the IP address from the spec to the status.
That's the work I was referring to that has been on my to-do list. That is, in addition to reviewing the cluster inventory stuff, is like now actually my priority. So,
Okay.
yep.
Okay, great. That's it.
But yeah,
Oh.
thanks for your work in the conformance test run again, John. That's going to be hugely helpful as part of actually like making some progress to move this stuff forward. So yeah, I'm really excited about this.
Yeah, definitely.
Yeah. Yeah. It's really useful. And so, yeah, Arthur had a topic but removed it.
Yeah, it's fine. It's 3 minutes. I will do it like on the next meeting. No worries.
Okay.
Not pressing.
Yeah.
Also, one quick request. Could you please put the links to these PRs that require a review or approval in the meeting notes so that a number of us can take a look and maybe we can get it approved more quickly?
Yeah. Well, the cluster profile rename kit is linked in the notes for a fortnight ago.
I just added
On the
it,
second page. And oh yeah, it's just been added there. And John's PR is linked in the notes already as well. Okay, well, I guess that's the agenda for today. Although we could continue discussing the workspaces concept, but there's not much point restarting that for 2 minutes. So thanks everybody for attending, and see you around. See you in 2 weeks' time.
See you later. Thanks, everyone.
Take care, y'all.
Yeah.